Hi guys, we've been doing some videos on recurring decimals and fractions, and I thought I'd have a look at just how you would convert a fraction into a recurring decimal. And the one that lots of people know is a third, and in order to make that conversion you would have to do how many threes go into one, and you can see that's 0, remainder 1, which goes there onto the next 0. 3s into 10 are 3, remainder 1. 3s into 10 go 3, and you can quickly see that that's going to carry on forever. There's no way you could stop, because it'd always be 3, remainder 1. So we've got 0.3 recurring. And division is the key to creating a fraction, creating a decimal from a fraction. We know that this means divide. And this goes outside. And this is inside. And you know, if we had to do, like, let's pick something fairly easy. Let's go for 5/12. I would know that I would have to do twelves into 5. And I already know that it's going to come out as a recurrent decimal, because in an earlier video I spoke about this denominator being so key. Because this is 2 times 2 times 3, I know that the 3 makes it going to come out as a recurring decimal, remembering that it would only have to be made up of 2s and 5s for it not to be recurring. So you can imagine most fractions come out as recurring decimals. So 12s into 5 go 4, 0, remainder 5, so 12 into 50 go 4, remainder 2, and then go 1, remainder 8, 12s into 80 go 6, remainder 8, 6, etc. So here we've got 0.416 recurring. We'll just put the dot above the 6 to show that that's the recurring one. Now there are some interesting ones. My favourite ones are sevenths. So if we look at a seventh, and I'm going to put that in there, so 7 into 1 doesn't go. So I'm going to go 7 into 10 go 1, remainder 3. 7 into 30 go 4, remainder 2. 7 into 20 go 2, remainder 6. 7 into 60 go 8, remainder 4. 7 into 40 go 5, remainder 5. 7 into 50 go 7, remainder 1. And so then we're back again to the 1. So you can see the pattern would then carry on. So this comes out as 0.14285.7, and the whole pattern repeats. So we put the dot at the beginning and the dot at the end. Now at the moment that's nothing too fascinating. When you look at 2 sevenths, I'm just going to do this one on my calculator. 2 divided by 7 is 0.285714. And if I look at 3 sevenths, I get 0.42857.1. Hopefully what you can start to see is it's always the same digit in the same order. 142,857, 142,857, 142,857. So if I was to look at 4 sevenths, Okay, so I've started on the 1, and I've started on the 2, and I've started on the 4. The next one I really need to start on is the 5. So that would be, oops, should go there, 0.571428 and 5/7. So instead of starting on the 5, I'm going to start on the 7. That's the next biggest one. There's 0.714285. And again, the numbers are in exactly the same order. 6/7. I'm going to start at the 8 because that's the next biggest one, because I've done the 1, I've done the 2, I've done the 4, I've done the 5, I've done the 7, I've got the 8 left to do. 0.85857142142. I shall just check that on my calculator, make sure I've not made a complete idiot of myself. 6 divided by 7, 6/7, which is 0.857142. So if you're asked, or if you ask a maths teacher what their favourite fraction is, it's likely they might talk about 7ths, because 7ths have this unusual pattern, and really quite unusual pattern, a sequence of 6 numbers that every time you go on to the next 7th, you always start with those, you always have those numbers in the same sequence, in the same order, but just starting from the next biggest number in the sequence. So 1/7 starts with the 1, 2/7 with the 2, 3/7 with the 4, 4/7 with the 5, 5/7 with the 7, and 6/7 with the 8. I hope you find that interesting, because I think that's really cool.